Hi Morgan, we're disappointed to hear you're not well yet, so I heard that you just need to get your strength back and stop coughing and all that, so we're with you. So we're starting a section called Trig Integrals, and this is from the blast from the past. So I didn't tape it, I just going to show you it right now. Here's 1, 2, if you would just copy these down. These are ones you should know or have seen and feel comfortable with. What was this one first? This one was just secant x. Alright, and this one must have been cosecant. Alright, so it's a little hard to read through here. Number 6, 7, 8, 9, 10, and 11 was our grand finale. So you're going to have to stop the video to get these down, but not you, Gianni, Morgan. But when we got here, this is where I wanted to sort of stand and observe and soak it in. We found out that we could do the integral of sine cosine by assigning u to sine and cosine u is du. So we end up integrating u du, which is u squared over 2. And in this case, sine squared x over 2 plus c. Alright, so Jonathan, I'm sorry. I'll have to show you where they are in the book because I need to have some board space. But I'll leave this. This is the main one I want out of you today anyway. This is sort of icing on the cake. So I'll leave 7 through 11 there. Alright, so to do the trig, in my book I had like 15 examples to do. I'm not going to do that many, but I guess we've already got up to 11. But what I'll do is I'll get you to a point and I'll drop you off. So it's like we're going for a ride here. First one of interest, this is more like today's work that you're going to have to do. Alright, so here's a spot where maybe you would need my help. Sine cubed x cosine to the 4th x dx. So I said it would have something to do with number 11. So what I'm going to tell you to do is the strategy, and then let's see if you can do it. The strategy is you want to save. I'm going to save a cosine or a sine. Actually, you do have a little bit of choice. Let's save a sine. Save a sine x. And you'll see what I mean by save in a minute. So this is our strategy for a lot of the ones that look like this. We're going to save a sine x and change everything else. Change the rest to cosine. So how shall we do that? Well, if I'm going to save a sine out of that, I'm going to have to pull one out. So I'll pull out one sine x. That's the one I'm going to save. And the other ones that are left would be sine squared x. And cosine to the 4th is unchanged. So there's a trig ID that will change sine squared to cosine squared. And this is... chocolate is awful. Alright, sine squared plus cosine squared equals 1 is the trig ID that will allow me to do that. So, Aaron, how can I rename sine squared using this trig ID so it's only cosine squared in the expression?
I don't know, would you have to like set the expression equal to something?
Pardon? Just rearrange this.
Oh, okay.
So you've got sine squared right there. So.
Oh, so you subtract cosine.
Right. So sine squared is going to be 1 minus cosine squared.
Okay.
Is that all right?
Mm-hmm.
All right, 1 minus cosine squared is going to take the place of sine squared. So let me move that down here. Can you foresee what I'm going to do next? Any ideas? Because a lot of these, the authors will ask you to sort of memorize strategies, and I prefer that you kind of pick your brain and come up with the strategy. Once you see this, you know what you're looking for. So, Brendan, what do you think I'm going to do next with this mess that I've created?
Are you using this yet?
Yeah, I need to, but I'm not ready yet. Can you see what do I have to do first before I can use this idea? Gianni? Oh, Brendan's got a light bulb that went off.
No, I don't.
Gianni, do you see what I'm gonna do?
Do
I'm trying to get it to come out of your brains instead of me telling you.
you have to distribute something?
Yeah, right. So what am I gonna multiply? I am going to multiply, this can be, let me write this over here alongside of this so it looks better. It is one term, so this I'm going to multiply times this and this times that. So back to you, Brendan, since you didn't get to answer anything. Would you please tell me what I get when I multiply this times this?
Oh, the cosine to the
Yeah, that thing that I put a box over times that.
cosine 4x
Uh-huh,
plus sine x.
sine x, not plus. These are held together by
Oh,
times.
oh, I
Okay.
gotcha.
Now, Brendan, I want you to distribute it to this one. And I'm gonna make a new integral, because we know we can do that.
Negative cosine 6x sine x.
Times what?
Sine x.
Right. And my dx's are falling out all over the place. Alright. Now, Aaron, what can I do with this now? It's going to be very much related to what I did over here.
Could you just try to fit it into that form?
Not quite, but we're going to have a u-du situation. What do you think
Okay.
du is?
Is the u cosine?
Yeah.
Cosine?
So if u is cosine, what's du?
Sine?
Almost. This is
Negative
derivative.
sign.
This is derivative. So we do have to mess a little bit with the negative signs. Put one in, pull one out. So can you do that in your head without me writing out this is u and so forth? What happens to this?
It's u to the fourth, so it would be 1/5 u to the fifth. Or negative 1/5.
And what is, negative 1/5. And instead of saying u, what is,
Cosine to the
right.
fifth.
Hopefully by today you can do that without writing out u du, but if you can't, write it out. But I'm hoping that you can go right from this. You do have to mentally pick up that negative sign, so you might want to write it down, but I can pretty much do that mentally. I know this is going to be cosine to the 5th over 5 at least. Alright, so Brendan, I'm asking you to do a u du thing over here. And what's that going to come?
Negative 1/7.
Alright, now is that including this negative?
Oh, so it'd be the plus.
Alright, so you're gonna put a negative in and pull a negative out, so you've got a plus, and then what?
1/7 cosine to the 7th.
Right,
Miss Todd, wouldn't the other one be positive too then?
I know, it could be. Where's that?
Because it's negative inside and then you have one outside too.
Yeah, well, this is this negative and this form the du. So,
Okay.
so I know.
Okay.
Alright, so sometimes I forget that too, like why did I put that in? It's because it's the du and it does not affect the final result. Alright, so let me check this. Alright. So could you recap for me, Gianni, what we did to get this problem?
You saved a sign,
What do you mean save a sign?
pull one out, and then distribute it with the cosine and change the remaining signs into something else, into cosines,
Right, and how do you do that?
using the trig ID.
Alright, it's this trig ID every time. There's another one I'm going to use today as well, but for a while that's going to be the only one. Then what?
And then you distribute the sine times the cosine in with the changed sine
Right.
squared.
Right,
And then after you distribute it, then you set up two separate integrals and integrate from there
And how do you integrate those last ones?
with u substitution.
U substitution, all right. So this is going to be pretty much a good strategy when you have an odd number of signs here. So if it was even, could we do that? Because we would pull out a sign and it would be how many, say this was sine to the fourth. So Aaron, if this was sine to the fourth and we pulled out 1, how many would be left?
3.
Right, and that doesn't match the trig ID. But if it was 6, and or say if it was 5, and we pulled out 1, how many would be left?
4.
And then we could use this one twice, but it'd be icky. It'd be icky. I'm sure I'll ask you to do that at least once. All right. Would you try one on your little lonesome? I want you to try, let's see one similar to that. How about if you get this one set up? Well, I guess this is exactly what I just said. Let's just leave that right there because I don't have all day to do this next one. Let's let me say, if this is sine to the fifth, when you pull out one of your signs to save as a UDU sort of thing, then you change this back to cosine, you're going to have 2 of these. So you're going to have to distribute all that out. So, and then multiply it times whatever's on either side, so it can get messy fast. All right, I did the homework though, and they didn't seem, that's why I'm going to skip this example and just point it out to you. All right, how about, let's try one where the power of cosine, I think you could probably do this. Try this one with the from what you've seen, and I'll jump in and help you in a few minutes. I'll put it up here in blue. The integral of cosine cubed x over the square root of sine x dx. So first step, you want to move the sine x from the bottom to the top, where it'll take on an exponent that will allow it to do that. So see if you can do the same strategy, except this time you're not going to save a sine x, you're going to save a cosine x, because that's what's cubed here. So you're going to take one out and save it, then you'll have cosine squared, and that will, you'll be able to mess with this trig ID and change it to sine. So we're going to just save a cosine and change the rest to sine. So it's sort of the same strategy with the other function. So see what you can get on that.
Should we pause the video?
Yeah, that'd be good. It's probably time to do that now anyway. We'll be back.